We can start our business now. So, Assalamu alaikum and a very good evening to you all. I am Sultan Ahmed, Associate Director at BIGM. I thank you all for joining today's webinar. This is the fourth webinar organized by Reform that aims to disseminate knowledge on crucial topics by distinguished faculties and practitioners from the respective field across the globe. We at Reform aim to give Bangladesh a new scholarly face that the world values. Our mission is to bring researchers together through knowledge sharing and to innovate and enhance the productivity and technological advancement of Bangladesh. At this stage, I would like to inform you that our Honorable Director, Dr. Mohammad Tarek, a legendary civil servant and formerly Secretary, Finance Division, Government of Bangladesh, and an eminent economist is present with us. So thank you, sir. I would kindly request Dr. Mohammad Tarek to say a few words, to share a few words with the audience. Thank you, sir. Over to you.
Thank you, Dr. Sultan, and let me start with heartfelt thanks on my behalf and on behalf of BIGM to Professor Dr. Tanveer Ferdous Saeed for accepting our invitation and presenting his research work in this platform. Reform is basically RE comes from research, and FORM comes from platform. Reform is an online research platform, as already pointed out by Dr. Sultan, that its first objective is to connect budding researchers with established researchers across the globe, so that knowledge can be disseminated and enhanced, so that the productivity of Bangladesh increases over time. Individual productivity, collective productivity, and as a result, the technological advancement of Bangladesh, we assume, will be facilitated. There are 2 or 3 basic assumptions behind forming this platform. One, that research in any subject nowadays is basically multidisciplinary research, or more specifically interdisciplinary research or transdisciplinary research. BIGM, as a policy research institute, as an institute of development, as an institute of governance, believes that these are the issues that needs to be addressed, look into, tackle from multidisciplinary lens. Secondly, whatever the domain is, it may be medical, it may be engineering, it may be economics, it may be political science, and there is a set of techniques and tools that we all are using and will be using. First, the statistical tools, second, the mathematical tools, and third, the computer tools. So reform is basically assume that within any discipline or a collective disciplines, we will be looking or doing research that will be multidisciplinary in nature and interdisciplinary in natures. And through this, we will be able to connect the budding researcher of Bangladesh with the established researcher of Bangladesh working in the country and also working abroad. So basically, this is an online platform to connect researcher to researchers so that the total productivity of the researchers and Bangladesh will be maximized. With these few words, I would like to end here, and over to you, Dr. Sultan.
So thank you very much for your kind words. Now today, our today's speaker is eminent scientist, Professor Dr. Tanveer Ferdous Saeed. Dr. Saeed is a civil engineer from Bangladesh University of Engineering and Technology and did MSc in Environmental Engineering at Asian Institute of Technology and PhD in Civil Engineering from Monash University, Australia. Dr. Saeed worked at Australia University of Science and Technology as an assistant professor. Then he joined as associate professor at University of Asia and Pacific, and presently working as professor in the same university, that is University of Asia and Pacific. Dr. Saeed is specialized in the fate and mathematical modeling of pollutants removal from wastewater, and published many peer-reviewed articles on pollutants removal dynamics in constructed wetlands systems. He has been serving as a peer reviewer of many international journals. Dr. Saeed is the chief author of Environmental Sanitation, Wastewater Treatment and Disposal. University Grants Commission published this book, and the book has been taught as a text or reference book in technical universities at home and abroad. Dr. Saeed received many research and academic awards from Bangladesh University of Grants Commission for Best Research in Engineering and Technology. He also received Bill and Melinda Gates Foundation grants. He has been included in the 2% scientist list of the world published by Stanford University and Elsevier in 2022. Dr. Saeed is the pioneer in introducing constructed wetland systems in Bangladesh for treatment of wastewater and polluted surface water. Today, Professor Tanveer Ferdous Saeed will speak on constructed wetlands, a low-cost natural technology for environmental protection in Bangladesh. For this webinar, to make it a good audible one, I would kindly request our participants to mute their microphones during the presentation. A question and answer session will be held after the talk, and you will be able to ask your queries and questions at the end, but you can put your queries, questions at our chat box, and then we will take it. At the end of the presentation, I hope Professor Tanveer, Professor Saeed will answer your questions and queries. We are very much grateful to Professor Saeed, and now I would kindly request Dr. Saeed to take the floor. Thank you so much, Dr. Saeed. Wish you all the best.
Thank you, Dr. Sultan, for inviting me here in this platform. Today, I would like to present my research work, some of my research works on constructed wetlands that I have been conducting in Bangladesh for the last 11 years. Actually, 1 hour presentation is a very long one. I myself sleep in these long sessions, so I would try to make it interesting. Okay, let's start. First of all, what's going on? First of all, I would like to define constructed wetlands.
Sorry, can you put it in slide mode?
Okay. What is this thing?
Yeah, it's okay now. Okay, thank you.
So constructed wetlands, actually these are natural green systems. They have been introduced in the 90s in Europe, and gradually it spread in Australia, Asia, North America, and other continents of the world. And now this treatment system is dominating over the traditional system, activated sludge process, because it is green, low cost, and easy to operate. But the disadvantage is it requires huge amount of land. But the wetland scientists, they are now working to reduce the amount of land, and we will talk about it later. So constructed wetland, it has 4 components, or mainly it has 3 components: plants, media, and the bacteria. And wastewater, obviously, it is not a component, it is the influent. So basically, the pollutants that is coming in with the wastewater, that is decomposed by the bacteria that live inside the media. And plants, they assist the growth of bacteria. And plants also, they uptake the contaminants, because we know plants, they require nutrients, but that is very negligible compared to the overall removal. But again, presence of plants is there, it is necessary, because without plants, we will call it as filter. Filter means it will include some stones, and it will be purified by physical process, for example, sedimentation. So these constructed wetlands, these are very similar to the natural wetland that we see in the nature. But we, the engineers or the scientists, we construct it. And the only purpose is to treat the wastewater. So here I'm showing you some examples of the constructed wetlands. These are classified, this can be classified into 3 groups. I will talk about it actually in 4 groups. So number 1 is vertical flow, and number 2, horizontal flow, surface flow, and floating wetland. Now this vertical flow and horizontal flow, these are defined as subsurface flow. Subsurface flow means wastewater is moving beneath the media, so you cannot see the flow of water. So we will see, okay, it's a very beautiful garden, okay, very nice. But if anyone doesn't tell us, we will not be able to understand that it's a treatment system. Whereas the surface flow, we can see the flow of water, because wastewater is flowing above the media. So this is very similar to the natural wetland that we see here in Bangladesh, or maybe in other parts of the world. And a very new system is floating wetland. Here the wetlands will float with the help of air buoyant mat, so that the mat floats on water, and the roots will grow inside the water column, and bacterial removal will occur here in the root. So basically, there are 3 types of wetland: subsurface flow, that is vertical and horizontal, then surface flow, and then floating wetland. Now this vertical flow, why we call it as vertical flow? Because wastewater flows vertically through the media towards the outlet. That means wastewater is flowing under gravity. That's why we call it as vertical flow. Whereas in horizontal flow, wastewater flows horizontally in saturated media. The media will be totally saturated. So we will call it as horizontal flow wetland. Okay. So now I will talk about a few of my research work that I have done in the last 10 years. So first of all, I will talk about the conventional treatment systems. These systems, vertical, horizontal, surface flow, floating wetland, these are conventional. They have been introduced 2 decades ago, or maybe 3 decades ago. So we have implemented these in Bangladesh. And this is the first reported study of wetland system in Bangladesh in chemosphere in 2012, so a decade ago. So we have treated tannery wastewater. We all know tannery. It's a very harmful effluent that destroyed the river Buriganga. And it is very difficult to treat, because the chemical composition or the bacterial composition is so complex that even the traditional system, for example, the activated sludge process, we require very intense monitoring for the successful treatment of tannery wastewater. Now, in 2011, this work was done when I was in Stanford University in 2011. We have employed this system for example, a 3-stage system. The first stage is vertical flow, that I have shown you before, then the horizontal flow, and then the vertical flow. And the media, this media is very important, the selection of media, because this is the main ingredient that will foster the growth of microorganisms. Also, it will absorb the pollutant, it will filter the pollutant. So many complex mechanisms occur actually inside the wetland system, and also it will promote the growth of plant. So here we we considered cocoa-peat or maybe coir. We call coir, waste product, coir. And here for the horizontal flow wetland, we considered cupola slag. This is the cupola slag. This is the waste product that we get from iron industry. And then the pre-gravel, small gravel that we get from the construction that is available in Bangladesh in construction sites. So this is a three-stage system. We collected the wastewater from a tannery industry in, I think, Hazaribagh. The tannery industry were located in Hazaribagh in the year 2011. Now they have shifted. And we have dosed them in this three-stage system. And here we have mentioned some removal performance. I will not go in details, but I will focus on some key points. If we look at the pollutant concentration here, this is the pollutant concentration of raw wastewater or raw tannery wastewater, like ammonium, nitrite, BOD, COD, like COD 11,500 milligram per liter. This is actually lethal for any receiving water bodies. Or also ammonium, 111 milligram per liter, and ammonium above 0.1 milligram per liter or maybe 0.2 milligram per liter is toxic to many aquatic organisms and plants. And the output is promising. We have got the overall treatment efficiency, for example, for all the pollutants above 80%, except nitrite, because nitrite in wetland system, it comes from ammonium to nitrite and then to nitrate, and then it will be transformed to nitrogen gas. So we will not consider this nitrite or nitrate because it has been actually transformed to other form of nitrogen. So this is very promising. And the effluent concentration, for example, ammonium was 15 milligram per liter from 111 milligram per liter. And if we look at the COD concentration, somewhere from 11,000 milligram per liter from the tannery wastewater to the effluent, that means the output is 0.2 milligram per liter. So this is very promising. This system, like this particular study, the first wetland study, we have found that constructed wetlands can be employed for tannery wastewater treatment either as a sole technology or with the traditional activated sludge process that the industries they have constructed. The effluent that is coming out from the traditional system can easily be passed through this wetland system, and we can further polish the tannery effluent and meet the guideline, DOE guideline. Actually, the DOE guideline also in 1977 DOE conservation rule, that has to be modified because very few parameters are included there. So I think they are now modifying it now. Our next study, when I was in Asomla University, that was textile. Because this is textile, it is another dangerous effluent. And the main component of textile that destroys the environment, we know dyeing, coloring compound. And this work was published in Bioresource Technologies. And here we have employed again vertical and horizontal flow wetland. And I would like to focus that here in the vertical flow wetland, we use sugarcane baga, the akhet chobra, waste product. In most of my research work, I focused on waste product because waste to reuse, waste to resource. So this will be now considered as a resource because we are using it to remove contaminant. And in the following horizontal flow wetland, we have used sillet sand. Sillet sand, we all know, we find it in the construction site, very cheap material. And again, results are very promising. Here again, in the like the COD, the ammonium concentration in the textile effluent, it was 158 milligram per liter. Again, COD, 12,625 milligram. This is absolutely lethal. BOD 5, 2,000, above 2,705 milligram per liter. And the effluent discharge criteria, according to ECR 1997 guideline into inland water bodies, maybe BOD, I think, I remember 40 milligram per liter. Where is 40 and where is 2,705 milligram per liter? Absolutely no comparison. But our systems, it produced very, very high promising removal performance, above 80% of all pollutants. And especially you see the color. This is the absorption coefficient. The color gradually reduced first, it reduced in the vertical flow wetland and then finally reduced in the following wetland of both systems. So this is the absorption coefficient. You see the absorption coefficient at defined wavelength. it has reduced. Actually, the color removal, depending on based on the wavelength calculation, was 90%. So it was very, again, it was a very promising result, and we were very much encouraged with the findings. So in 2019, or maybe I think 2018, we have collected in the mixed industrial wastewater from Shampoo. In this Shampoo area, it includes different types of industries, and all the wastewater are mixed, and then it is being disposed through a common channel. So we collected that wastewater, and again, we treated it in two-stage system. Here, the interesting thing is, in one system, we use recycled brick. That means the brick from a demolished structure. We resized it according to our requirement, and then again, we used it here in one system, and another system, same, that sugarcane bagasse. And here, interesting thing is, we found that this recycled brick, it produced more promising result than the sugarcane bagasse, because the recycled brick, it has many chemical components. We will see later in EDS analysis. We have the EDS analysis but due to space restriction, I couldn't show. It has many chemical ingredients, for example, calcium, aluminum, iron. These elements, they promote the absorption of phosphorus, and also these media are very porous and rough. So they promote the growth of bacterial surface. We will see in the ACM analysis later. So this is a very effective media. And here we have used Canna indica plants. And in the previous two research, we have used phragmites, a very common plant we find in Bangladesh. And the results are again very promising. We have achieved almost 80 or 85% removal from the industrial wastewater. And again, if we look at the effluent concentration, we see the COD effluent concentration was 1098 milligram per liter, whereas the effluent concentration reduced to, like in this system, from the first to say 184 milligram per liter, almost 75% removal. So very good removal. And again, another dangerous pollutant, total nitrogen, 17.3 milligram. But again, at the end point, this system, the recycled brick, we got 3.4 milligram per liter. And color removal was also sufficient in terms of platinum cobalt. Color was 1197 platinum cobalt, and at the effluent, it was 209 milligram per liter. So this research, it bridges between structural engineering and environmental engineering, because brick is a structural product. The civil engineers consider brick as a structural element. But here in this research, we have shown that the structural element can be also used to the environmental division. So bridging the two divisions of civil engineering. Now we will talk about floating wetland. In our previous three research works, we have talked about subsurface flow, that is vertical and horizontal flow wetland. But there is another form of wetland, that is floating wetland. In these wetland, we use air buoyant mat, and we put plant, any plant that is water tolerant. We do not expect that rose will grow here, any water tolerant plant, and particularly polluted water tolerant plant. So what will happen? Roots will grow inside the water column, and bacteria will grow here. So wastewater will pass through the media, and the pollutant removal will occur in the rhizosphere. So actually, this root, it will act in lieu of media in the floating wetland, and the whole system is floating. That's why we call it as floating wetland. And this floating wetland is very applicable for Bangladesh, particularly for industrial wastewater treatment, because we know industries, they dispose wastewater, it comes through a channel and then it meets the river. If we put the floating wetland barrier in those channels, it will reduce the pollutant before it goes to the river. And we know that river has a self-dilution capacity. Once the pollutants have been reduced, the river, due to its natural capacity, will remove the remaining pollutants. So this could be a very attractive option also to treat our polluted lakes, for example, Hatejil or other lakes. And here you see the bulk root zone, the growth of the root and the plant on the mat. So we have also implemented this floating wetland in 2015. It was published in a very prestigious chemical engineering journal. Its impact factor is now 17, almost 17. So here what we did, we have constructed a very large concrete built tank, and we filled it with the river water collected from Buriganga. And then every week we collected river for Buriganga and we dosed it here. This was the initial system, and this is the very matured system. The root growth of the initial system, very small root, and look at the matured root growth here. So what happened here? Again, we see the ammonium concentration in the Buriganga river. It was very high, 50 milligram per liter for a river. It's not good. And the effluent was, after treatment, it was 4.4 milligram per liter. So all here I have shown, it's a very complicated table, but it has shown promising removal from the promising removal of contaminants from the polluted surface water. But again, we cannot put it in a river because river is vast. But what we can do, we can put it in the canals through which the industrial wastewater passes towards the river. So this is an example that the floating wetland could also remove the contaminants from the polluted surface water. And another work we have done in 2019 in Journal of Environmental Management, we have treated wastewater from Hatijil Lake. But here, these are the first stage vertical flow. But here, the second stages are very much, could be easily applied to the polluted lake. For example, surface flow or floating wetland. And this is the initial, this is the mat that we have constructed for this floating wetland and the root growth after the experiment ceased. And we have got promising result from these. As far as I remember, most of the pollutants made the guideline of inland water bodies, ECR 1997. Now, we moved to a very ambitious wastewater. That means landfill leachate. What is landfill leachate? We know that every day the million or maybe 1,000 tons of solid waste are produced from each of the city corporation or maybe from Paurosabha. All these wastes are compiled in a vast area. These are managed by the city corporation or the Paurosabha. And when we compile the waste, what happens when due to rainfall or due to the drying process of the solid waste, the liquid portion of the solid waste comes out, and that we define as leachate. And this leachate is one of the most dangerous wastewater of the world because it has very high pollutant concentration and it is very difficult to treat due to its imbalanced chemical composition that doesn't support the growth of microorganisms in any treatment plant. So this was our first study with landfill leachate. Here we have used 3 parallel stage wetland, and again the media in the wetland system. The first one is gravel, that means normal stone, and this one is very interesting. You see, this wetland was filled with steel slag. The slag, the byproducts used from steel industries, and the concrete block. That means the concrete. We know that our buildings are made of concrete, so we use that concrete. And the third system, it's a little bit complicated. I will not explain because it requires some engineering explanation, and we do not have time. And as in the second stage, again, this is the horizontal flow wetland. That means where the wastewater flows horizontally, and this is surface flow and floating wetland. Our concern, or I would like to focus on this system because this waste-based product, it removed the pollutants from the leachate. If we see the pollutant concentration of the leachate, we can see COD concentration almost 900 milligram per liter. And the most lethal is nitrogen, total nitrogen. This is 225 milligram per liter. This is absolutely lethal. And its dominant form was ammonium. You see, 156 milligram per liter. And as we know, with many aquatic organisms, they cannot tolerate ammonium concentration above 0.1 milligram per liter. So this was a very complicated leachate, and we collected it from the Matwai landfill. Thanks to them. And again, they also have a treatment process. They treat it through a pond system that is also working, but also they are working with us now. And we have produced effluent concentration, not bad. For example, ammonium concentration, the surface flow from this system, it reduced from 156 to 1.9 milligram per liter. Now, this is absolutely tremendous, because if we can produce an ammonium concentration near around this 1 or 2 milligram per liter, the nature will remove the remaining ammonium through natural purification. And again, the BOD, another dangerous pollutant that consumes oxygen of the stream or lakes, dissolved oxygen. It was 350 milligram per liter, and this was from this system, it was 24 milligram per liter. So it almost made the ECR guideline. Our main theme was, we are not claiming that you have to use this system, identical system. Our theme was, okay, this system can remove pollutant, so it can be easily integrated with the existing pond of the Matwai landfill. Okay, so again, we continued our journey with the landfill leachate, and this was a bit ambitious one, a setup. This is a very complicated setup, 4 vertical flow first stage and 4 defined types of horizontal and surface flow wetland. And again, if we look at the media, for the first system, we used concrete, again, reused concrete. This one is coal, organic coal. Organic media has certain advantage because it has carbon composition. This carbon composition facilitates the growth of microorganisms, particularly the denitrifying bacteria. So, and also it absorbs pollutant. Any organic media, for example, coal, biochar. Biochar is another very good organic media that is now employed worldwide as the wetland media, or maybe as the filter media. Again, this is cocoa peat, and this is again the brick. This is a very new thing that we have used in our previous research in 2018. And these are filled with sand. And this is the ACM images, which you see. This is the unused, these are the unused. That means fresh. And these are the used. That means we extracted it after the termination of the experiment. And these unused thing, we see rough textures, where the used product, these are the ACM image, we can see huge deposit of biolayer. That means form of aggregate based. It could be organic matter deposition. It could be deposit from plant, and obviously the growth of bacteria. And this was again the leachate composition. Here again you see the COD composition. If you look at the COD concentration, it was above 1000 milligram per liter. So again, it is very dangerous for the environment. Here we have also analyzed the plant for nutrient consumption, nitrogen and phosphorus, and then we compared with respect to total removal, and we have seen that for highly loaded system, plant contribute to only 1 to 3% or 1 to 5% nutrient removal, and that was also reported previously worldwide. But for low loaded system, plants they contribute through uptake, because in highly loaded system, the nutrient concentration of wastewater exceeds the uptake capacity of plant. But again, plant, this is very important. Whether plant, it is not a wetland, it will be a filter media or unplanted filter, we will define. So here this is the same setup, but this is another publication, because here we analyze the major pollutant, but here we analyze the metals, 4 important metals, that is zinc, chromium, nickel, and lead. Actually, metals removal in constructive wetland, it is totally physicochemical. For example, metals will precipitate in alkaline condition as hydroxide form, and also the media, they may absorb metal because they will media, if the media it has cations, for example calcium element, they will exchange, it will exchange with the heavy metals. Okay, and also if iron is present in wastewater, it will deposit, and this iron or manganese deposit will also absorb metals. And this is the EDS analysis of this media, EDS analysis. Actually, we have done most of this analysis in all research, but I'm showing you in this too, because we do not have that much space. And we can see different types of cationic elements present in this sand or brick. And all these primarily contributed to metal removal through precipitation, absorption, and plant uptake, nutrient uptake, metals uptake was negligible in fragmite or vetiver plant. And with the bioconcentration factor or total translocation factor analysis, we found that metals mainly accumulated in the root zone. And that was also reported previously, because plant has some self-defense to prevent the translocation from root to, from underground to above ground. But again, plant, they didn't contribute that much to metal removal. The main contribution was physicochemical inside the media. So this is a drawback again for metal removal in constructive material, because maybe after 2, 3, or 4 or 5 years, these cation, the elements will be exhausted in this material. So it should be replaced if we want to achieve metals removal. So this is a drawback of metals removal if we use constructed wetland. But again, this is a very low cost technology, so it has certain advantage over the disadvantages. We have also treated municipal wastewater. Municipal means the wastewater that is coming out from the city. Actually, a major problem of the constructed, like of vertical or horizontal flow wetland here, if we see, we are putting wastewater on the media surface, but we cannot flow the control of wastewater inside the media. For example, wastewater may flow straight, or it may flow zigzag, or there can many dead zone could exist. Dead zone means where wastewater, it doesn't pass. So we cannot use the full media in this traditional wetland. So here, what we use, we introduce baffle, that means dividing walls. So what is happening? Wastewater is coming now, due to presence of wall, it has to flow here. And again here, so it has to flow through the opening. So it is a zigzag. So we are using here, we are using the whole media. Similarly, in the horizontal flow wetland also, here, due to the presence of baffle wall, the water is flowing through the media. Whereas in the traditional system, for example, water is coming, maybe it flows through this way, or maybe through this way. We cannot control, because there is no control structure. That's why we have introduced control structures here. This was the first system, followed by second system, and then a surface flow and floating wetland system, a 3-stage system, a pictorial presentation of this 3-stage system. This was published in Journal of Environmental Science. And again, if we see the pollutant concentration of the municipal wastewater, this was collected from Tejga near Hathi Jheel. Like CO2 concentration, look, 4,400 milligram per liter. Obviously, because it contains also the textile effluent from the Tejga industry and also from other industries, and along with domestic wastewater. And this is going to the Hathi Jheel. This is going to the Hathi Jheel and polluting the Hathi Jheel lake water. I have told the authority many times. They told, okay, we will do something, and eventually nothing. So ultimately this is the final effluent of the 3-stage system. That means the effluent produced from the surface flow wetland. And if we see the CO2 concentration, the influent concentration of the municipal wastewater was the 4,048 milligram, and effluent was only 223 milligram per liter. So almost 94% overall removal, and also ammonium and other pollutants, very promising removal. So here in this study, we showed that if we use structures, flow controlling structures, we can improve the pollutant removal performance of the wetland system, because now we can force the wastewater to pass throughout the media. So this is another municipal wastewater treatment system. Here also, this was, as I told you before, this is a new system. We have inserted pipes. You see pipes. This is the cross section. If we see the top section of this system, and we have inserted several pipes. So what is happening? Wastewater is flowing through the pipes. So we are forcing a certain direction, a vertical direction. We are not allowing the free movement. We are forcing. And here we used mortar. Mortar means painting. That means what we use on brick walls. So our university was undergoing through a renovation process, and they produced huge amount of mortar. We collected it, we crushed it, and we used it as our main media in this system. And we have got promising result in this study when compared with other systems that was conducted worldwide. So here almost 90% removal. Now this is the interesting part is coming. Novel, that means very new treatment system that has been recently introduced. Number one is tidal flow. It's a very new system introduced worldwide. Tidal flow system means it is operated under 4 conditions. First of all, suppose this is a wetland, it is dry, there is no wastewater. We will fulfill, that means the media will be fully saturated. We consider it, we will call it as the fill period. During the fill period, what will happen? Media will absorb the pollutant. For example, ammonium, phosphorus, maybe metals. And we define this period as contact period when we saturate the whole media. And after the predefined contact period, it can be 1 hour, 2 hours, 24 hours, 36 hours, maybe 10 days. We have to design it. We will drain the entire wastewater from the system. We call it as the drain period. And then it will be kept unsaturated for a certain period. We call it as rest period. So these 4 sequential protocols, fill, contact, drain, rest, they contribute to pollutant removal. This is an engineered system or intensified wastewater treatment system. They require less amount of land. We have also introduced this system in Bangladesh in 2020. We used different types of material, for example, gravel, biochar, organic biochar, again concrete from demolished structure. This is coal, steel slag, cocoa peat. Here are the systems. And we have got very promising results from the municipal wastewater. But obviously, I'm not telling that we can implement it in a traditional treatment system, because it requires very sophisticated arrangement. If we have sophisticated arrangement, we can reduce the amount of land and we can go for this system. And these are all single stage. That means no, here what, if we look at the, we have seen 2 stage, 3 stage that consume land. But here we have got very high result using only a single system. So this is a promising system that can save the consumption of land. Now, a very recent system, that means microbial fuel cell wetland. Wastewater will be treated and simultaneously energy, bioelectricity or bioenergy will be produced. How? How we produce bioenergy? This is a conventional wetland system with media and plant. It can be any plant. We will integrate electrode, that means cathode and anode. Any electrode that will consume the electron. It can be steel, copper, etc., or maybe charcoal, whatever. So what will happen? Organic matter will be degraded here in the anode. This is the anode zone, and this is the cathode zone, and we separate it by foam. This cathode zone is aerobic, and this anode zone is anaerobic. That's why we have put foam. Otherwise, roots will come inside the system and will destroy the entire system, because roots, they also pass oxygen, some oxygen. So the anode zone must be anaerobic. That means no oxygen will enter. And what will happen in this anode zone? electrogenic bacteria will degrade BOD or organic matter, that means BOD and COD, and they will produce electron. And this electron will be captured by the anode plate and will be transferred through the external wire and resistor to the cathode plate. In the cathode plate, there is oxygen. So in presence of oxygen, the circuit reaction will be completed and energy will be produced that can be detected by a multimeter. It's a very promising system, and this system is now gaining attention worldwide because renewable energy production. We have introduced this system very recently in 2020. This was our first published result in, again, this chemical engineering journal in the year 2021. This was the 6th bioenergy producing system. We have used organic biochar, coal, jute fiber, steel slag, third class brick and concrete block. So these are biochar, coal, jute, these are organic and these are structural materials. And very promising result, ammonium nitrate, and we also measure other polymer. I am not showing it. Almost 90% removal from municipal wastewater. And this is the power density production. We have got very high power density production, particularly for the biochar system. Because biochar, it is organic. And electrogenic bacteria, they require carbon for their metabolism. That's why it produces very high power density. We in our another paper, we have the main problem of this bioenergy producing system was lack of mathematical modeling. How the pollutants are removed. There were no mathematical or kinetic equation. We have proposed this equation in this paper. Very good, very environmental science and pollution research, impact factor above 5. So we have proposed this equation, and with this equation, we showed how pollutants are removed in this system. This is the normal system, and this is the bioenergy producing system. We have compared these two systems. We have found these systems are very interesting, and we have integrated this tidal flow approach here. We remember this tidal flow. This one, field contact drain rest. So both this system and this system, these are tidal flow system. But here also we have integrated electrode, and with these equations we have shown how the pollutants are removed, biologically removed in the wetland system. So these equations, we hope that it would formulate the mathematical modeling segment of these wetlands, because these are very new systems. So no mathematical models were proposed until this research. What is this? Now, this was a very ambitious project. Microbial fuel cell wetland for landfill leachate treatment. Because landfill leachate, this is very dangerous. This has very high COD concentration. And that could destroy the anaerobic anode environment. But that's why we have designed 4 parallel system, vertical followed by, but this is unplanted filter, same media, and but here this one is Cana indica. So the difference between these two systems is inclusion of plant, and again this one same with this one, but inclusion of electrode, and here multiple electrode. We found that this multiple electrode was very efficient in reducing landfill leakage. What we did, we did intermittent loading. That means, for example, our daily dosage volume was 5 liters. So we divided it into 6 or 7 parts. So each time we applied small amount of wastewater so that the chemical composition doesn't destroy the anode environment, and it worked. So this research also showed that microbial fuel cell brand can be used for high strength wastewater treatment, provided that we use intermittent loading. But if we apply the whole load altogether, it will destroy the anode chamber as reported previously. And here also we measured the absorption of the media. Actually, we measured in all research, but here I am showing you how the pollutants were absorbed. And this was the EDS nutrient concentration of the unused and used media. we have measured in our all return, but I'm showing it here. We have seen a significant accumulation of nutrient in the media because this media, as we have shown, we have seen in the previous in our previous EDS analysis, that these include calcium, aluminum, iron, and also cation ions. So these were absorbed or exchanged, and these are the voltage production. Very random, very irregular voltage production because due to depending on the load volume. And this was published again by another prestigious journal, Science of the Total Environment, recently, very recently. Pardon? Okay. Now, a different aspect, sludge. Sludge, the product or residue we get from treatment plant, we get from our septic tank. Any residue that is considered as sludge, and this is very dangerous because the sludge, it has high water content and it has huge chemical and organic nitrogen or metal. So you cannot dispose it directly. If you dispose it directly, it will pollute the environment. So this is the overall sludge treatment mechanism of a wetland system. Here I am showing you the microbial fuel system, but wetland system also similar. When the sludge is subject to drying period, evapotranspiration, plant evapotranspiration, we reduce the water content, and also the growth of root will create crack that will increase the draining of the wastewater that will be treated by the underlying media and the bacteria, and also physical and chemical absorption will occur. So it's a very complex process. We have also implemented normal and microbial fuel cell wetland for sludge treatment. We collected it from the Saeed drinking water treatment plant. They allowed us, and we if we closely look at the system, this is unplanted, this is planted. Here we have introduced in the sludge there, we have introduced earthworm, because earthworm, they have burrowing activities, and these burrowing activities, it creates pores. So it will enhance the atmospheric oxygen diffusion that will allow dewatering and sludge stabilization. And this is again microbial fuel wetland. This is similar to this one, but with earthworm system. We found this system is very effective compared to other systems because due to the existence of defined chemical and electrical based reactions that contributed to wastewater treatment and also sludge stabilization. And the total solid content is very high for all systems, particularly these two, almost 90%. So it can be very safely applied to the land. And here we have also measured the nutrient concentration of the sludge. And that was also published in Chemical Engineering Journal. A very interesting research that we are conducting now is septic tank sludge treatment. This is funded by Bill Gates and Melinda Gates Fund. And we collected septic sludge, human waste from septic tank, and we treated it here. I'm not showing you the result because we are writing the manuscript right now, so we cannot show the result right now. Hopefully, inshallah, after it is published, we can show the result. And look at the end product that we have produced. And we have undertaken detailed chemical analysis, for example, metal, all types of analysis. And we have found that the products produced from this system, they have made the agriculture guideline as published by the DOE as fertilizer. The metal guidelines and the solid guideline and organic nitrogen ratio, it has made. But I will emphasize that we need to improve this guideline because we do not know that maybe the human waste of the septic tank, it may contain antibiotics, because our tendency is we frequently throw medicine in our basins, and this is going to the septic tank. So this guideline has to be included here. And obviously we have not measured this aspect, antibiotic, because due to lack of measurement protocol, but maybe in future, we hope. Now what is happening? Okay. So this now our last topic, decentralized wastewater treatment. That means septic tank. The main problem here in Dhaka, we use two-chamber septic tank. This is a partial treatment system. So it just allows sedimentation and filtration. So the wastewater coming out, actually it is partially treated. It is very dangerous for the environment. So what happened with the funding we got from water aid, we developed this bioreactor septic tank so that pollutant removal occurs here in the biowalls, in the sludge, and then eventually it comes out. And also this system actually exists in a school of Mirpur area. The water aid, they constructed it. We constructed it. And we have got very promising effluent from the septic tank. We see BOD, the influent was 152. And look at the BOD, 0.7 milligram per liter. It's almost very suitable for reuse purpose. And also ammonium 30.5. And from this effluent, we get 1.1. So this is very promising. It can be easily applied. And it will, we hope that it may reduce the current environmental pollution in Bangladesh. And this is the ACM images of the media we have done. Very intense growth of bacteria. And we have also integrated a wetland. We have integrated it in with this system. This is an experimental system, particularly for the schools in Purosabha because they have land. And we have got promising results. And the results are published here. Actually, last 2 years, we have implemented some floating wetland in Dhaka, Diwasa, Saeedabad treatment plant intake. Our main objective was to purify the intake wastewater so that it reduces the load of Saeedabad treatment plant. And because we know that treatment plant, it is overloaded because they extract water from Shitalokkhorika. And this is the water from Shitalokkhorika. We have constructed some floating wetland. We have constructed almost 300 floating wetland and then suddenly water disappeared. I don't know why. Okay, maybe it's there 10 minutes. And last some few slides, our experimental setup. These are our experimental setup at UAP. Different types of running system now. These are running. Different types of system. This is the look, this is the sludge treatment system. Okay, this is the unplanted system. Water percolates very slowly here because due to absence of plant. And some very complicated system pumping and all timer control pumping to dose water. And this is the bioreactor septic tank that will produce electricity. This research is going on under another grant from Bill and Melinda Gates Fund and ITN WIT. And this is the voltage production, some very complicated connections, all voltages are coming from this setup. Okay. Thank you. I think I have finished early.
Thank you so much, Professor Saeed, for your wonderful presentation. Dear participant, now this is time for if you have any query or question, please ask. Raise your hand.
Maybe 1 minute gap for my drinking. I think
Okay, please have a drink. Okay.
Okay. We may proceed.
Okay, so Professor Saeed is ready for your query. I can see a lot of hand raised. I could not identify who raised first, but I will come from alphabetically from the top. Mahadi, you also raise hand. So please ask your question.
Thank you, sir, for giving me the opportunity to present my question. Am I audible?
Yes, you are audible.
Thank you. My first question to our esteemed speaker today is I'm really intrigued by the voltage production project, but my question is it scalable? That means, can we make it in a bigger form so that we can supply the electricity to the grid? And my second question is the cost effectiveness of the bioreactor septic tank. Is it really cost effective in comparison to the prevalent project? And my third question is regarding the longevity of the bioreactor septic tank. As it purifies the waste, there must be some time limit to the to the walls working on it, the purification walls, as you have described. How long do they work, or long do they last? And that will be all.
Thank you. Regarding your first question, for example, voltage production, actually,
Professor Saeed, maybe we can take some 2-3 more questions, and then if you respond.
maybe I think I will forget the questions.
Okay, then. Okay.
So, regarding the scaling of voltage, actually, this system has been introduced a decade ago. Now, our current objective is to optimize the pollutant removal using the electrogenic bacteria. But now, research is being undertaken for field scale application and for whether this can be supplied to power grid. But I think the main objective now should be of these bioreactors, maybe wetland system, to operate the pumps that it requires. That means self-sustaining energy, because you see, supplying it to grid, it will require somewhere around megawatt hour or maybe more. And it's right now it's not feasible to produce a huge amount of such a huge amount of electricity from this treatment. But research is going on. The researchers, they are now optimizing the electrodes, they are optimizing the media, but it will require some time, maybe, because it's a very new field, maybe 6 to 7 years. It will take some time to connect it with the power grid. Regarding your second question, I think, what was that? Bioreactor, septic tank, I think.
Cost effectiveness of the bioreactor septic tank.
Yes. Actually, this bioreactor septic tank, if we see the figure, this is nothing but the traditional septic tank that we use in our treatment in our houses. This is a two-chambered system, but here we have this two-chambered, but we have inserted some wall. Biowall means some concrete walls, and we have put some stone. Because you see, here in this system, it just promotes the physical separation of pollutant. So the pollutant that is wastewater that is coming out, it still includes huge amount of pollutant that will not fulfill in the guidelines in any part of the world, unless there is no guideline. Okay, so here it looks complicated, but the construction is not that much complicated. We will just construct two concrete walls and we will put stones. And regarding the time process, all the septic tanks, for example, this one or this one, sludge will accumulate and the depth of sludge will increase. So all the septic tanks, including this traditional or the bioreactor, it requires desludging. That means extraction of the sludge. Otherwise, the whole system will be filled by the sludge. Normally, the ideal condition for septic tank in Bangladesh, or these normal septic tank, it requires 3 to 5 years desludging. But I think most of the septic tanks, they forget that it requires desludging, and most of the septic tanks are now malfunctioning. Okay, they are generating pollutant. So this will also require the same time, 3 to 5 years. But if you do not desludge, again, what will happen? This system will be filled by the sludge, and then the following part will fail. So the same design guideline, 3 to 5 years, you need to dislodge it after 3 to 5 years, depending on the house population living in the household. There are mathematical equations for these types of techniques. Similar equations will apply here for this one also. Thank you.
Thank you, Professor Saeed. And we have some queries from Ms. Sabrina. What is the cost of floating unit and size? This is one. And I think she asked for any other plant. I mean, the reed bed or reed. She asked, do you have any plan? Do you have plan to incorporate any other plants than you have shown here? And then the third one is what are the media you used in floating unit? So these are the queries from Ms. Sabrina.
The common plants that we have used in most of our research, in our early research, is phragmite. This is the most commonly used plants worldwide because it can tolerate wastewater. But I have seen that phragmite, it has certain disadvantage. For example, when you put tannery wastewater or maybe leachate wastewater, it dies because it cannot withstand the exceptional high nutrient load of this wastewater. And another plant, this was introduced, I think, Department of Civil Engineering from WET, they are undertaking research with this plant, vetiver. I think it grows in Gazipur or somewhere in some areas of Gazipur, I forgot. I sent my students, they searched a lot, and then in a certain place they found vetiver. Vetiver, the advantage of vetiver is it tightly holds the soil. So the Civil Engineering Department of WET, they have widely implemented vetiver as slope stabilization in the Chittagong hill tracts, I think. And they have been funded, I think, by different organizations in Thailand. But in wetland system, they have also used vetiver. I have also used vetiver, but again, the same problem exists. Like when we put high strength wastewater, it dies. Okay, it turns yellow slowly and eventually it dies. Okay, but again, another interesting thing is, although the plant died, we found that the wetland, it continued its functioning because the bacteria, they have grown inside the system. And another plant, my teammates, they are researching on this plant. Okay, this I think this Canna indica plant, like this Canna indica plant, this can withstand huge pollutant load. But again, this is very interesting because we do not know whether these Canna indica plants they have been mutated or not. We're talking, maybe we need to analyze something about this plant because we do not understand. I do not understand why these plants grow enormously in such a polluted environment. They have grown enormously in fecal sludge system. And again, you see, this is the landfill leachate. When the phragmite died, they continued their growth. And again, this system, you see the phragmites here, they died. And look at they were growing. But we have to, we're now undertaking some research with Department of Soil, Plant and Environment with this part, because I'm not a plant specialist and I do not know, because my main concern is the removal that is going on inside the system. But we also need to identify this part, the particle strength of this Canna indica plant, because it could be a robust plant. It can withstand the shock, the high pollutant load and the ammonium concentration. But it requires some findings and we require some time. to make some conclusions about this particular plant. Because some other Canna indica plants we have collected from Dhaka, from the nurseries of Dhaka. They didn't grow that much, but these have been collected from Khulna, and they continued their growth. And see the flower here; they have continued their growth. So this is our another topic that we are now researching about the.
So she was asking again whether you have any plan to use Kusuripana. I mean, in the floor.
No. We have not used duckweed because duckweed it has some problems. Because duckweed we have to harvest it periodically, like 15 or 20 days. Because if we do not harvest, it will die and it will sink and it will reach the pollutant. We have conducted a research on duckweed, and then we found that okay, we need to harvest it every 15 to 20 days. Otherwise, it will die and it will leach pollutant. Whereas the Phragmite or Canna indica, we do not need to remove it. They continue their growth and continue in assisting the pollutant removal.
Okay, then thank you. And Umlan, you raise your hand. Please ask your question.
Thank you, sir, for giving me the opportunity.
And you down your hand first. Okay.
Oh, sorry, sir. There you go. Okay. Thank you, Professor, for your wonderful presentation. Can I ask my question in Bangla, because I think it will be like more.
Okay, sure.
Please.
আচ্ছা, আমার কোয়েশ্চেন হচ্ছে এটা বেসিক্যালি মানে বেসিক কোয়েশ্চেন হতে পারে, কারণ হচ্ছে গিয়ে এটা আমার হচ্ছে গিয়ে ফর্টে না। আমার জানার আগ্রহ হচ্ছে আচ্ছা মানে এখানে আমরা তো বেশ কিছু হচ্ছে গিয়ে টেকনিক দেখলাম যে ওয়েস্ট ওয়াটার ট্রিটমেন্টের জন্য, কিন্তু সবগুলা ট্রিটমেন্ট কি মানে এখন তো ওয়াটার বডি দুই ধরনের আছে, একটা স্ট্যাগন্যান্ট আর একটা হচ্ছে ফ্লোয়িং ওয়াটার বডি। যেমন হচ্ছে গিয়ে যে আমরা যদি নদীর কথা বলি, বুড়িগঙ্গা নদী, ইটস কনস্ট্যান্টলি ফ্লোয়িং, এখানে যে খালগুলো পড়ছে সেটা কনস্ট্যান্টলি ফ্লোয়িং। কিন্তু হাতের ঝিল কিন্তু হচ্ছে স্ট্যাগন্যান্ট। তো এখন যে ওয়েস্ট ওয়াটার ট্রিটমেন্ট যেগুলো, সেগুলো কি এখন দুই ক্ষেত্রেই কি সেম ভাবে হবে? এখন দুই ক্ষেত্রে যদি সেম ভাবে না হয়, যদি ফ্লোয়িং ওয়াটার ডিফারেন্ট হয়, কারণ বুড়িগঙ্গার পানি কিন্তু অনেক বেশি পলিউটেড এন্ড কনস্ট্যান্টলি হচ্ছে বিভিন্ন ধরনের ওয়েস্ট এসে পড়ছে। এক একটা ওয়েস্টের জন্য যদি এক এক ভাবে হচ্ছে আমাদের ট্রিটমেন্ট করতে হয়, তখন কিন্তু কষ্ট অনেক বেড়ে যাবে। এখন মানে যদি এটা সরকারের পক্ষ থেকে করা হয় তখন হচ্ছে এক ব্যাপার, কিন্তু যদি হচ্ছে যারা ফ্যাক্টরি গুলো আছে তারা যদি হচ্ছে গিয়ে মানে করতে চায় যে এটা ইনকর্পোরেট করতে চায়, তখন কিন্তু এক এক ধরনের ওয়েস্টের জন্য যদি এক এক ধরনের হচ্ছে গিয়ে ট্রিটমেন্ট হয়, তখন কিন্তু জিনিসটা কিন্তু অনেক বেশি কস্টলি হয়ে যাবে। সেটা তাদের জন্য একটা মানে তারা এটা করতে চাবে না বিকজ অফ দ্য হায়ার কস্ট। আমি চাচ্ছিলাম হচ্ছে জানতে যে মানে এমন কি কোনো হচ্ছে ট্রিটমেন্ট আছে যেটা হচ্ছে একসাথে ফ্লোয়িং ওয়াটার প্লাস স্ট্যাগন্যান্ট ওয়াটার প্লাস আবার সব ধরনের পলিউশনকে হচ্ছে গিয়ে ট্রিটমেন্ট করতে পারবে? এটাই।
থ্যাংক ইউ আপনার প্রশ্নের জন্য। অ্যাকচুয়ালি ফ্লোটিং ওয়েটল্যান্ডটা কিন্তু ফ্লোয়িং আর স্ট্যাগন্যান্ট দুইটার জন্যই। কিন্তু এখন হচ্ছে আপনাকে প্রথমে যদি হাতির ঝিলের প্রশ্নটা আমরা আনি, হাতির ঝিলকে কিন্তু আপনি আসলে স্ট্যাগন্যান্ট বলা যায় না, কারণ হাতির ঝিলের প্রবলেমটা হচ্ছে হাতির ঝিলে প্রথমে ওয়েস্ট ওয়াটারটা আসছে হচ্ছে সোনারগাঁয়ের ওইখান থেকে, সেখান থেকে কিন্তু পাস করে যাচ্ছে। এবং এই সোনারগাঁয়ের যে আপনারা যে ওই যে ইয়েটা ওই শাহবাগে যাওয়ার পথে যে ইয়েটা দেখেন, সেটা মেইন কিন্তু ক্যাচমেন্ট, পরপর 2-3টা ক্যাচমেন্ট আছে, এদিক দিয়ে পাস করে কিন্তু হাতির ঝিলে চলে যায়। এখন এই হাতির ঝিলে এই ক্যাচমেন্টে এই যে ওয়েস্ট ওয়াটারটা, এটা কিন্তু আশেপাশে পুরো একটা ওই ঢাকার ওই পার্টের ওয়েস্ট ওয়াটারটা পুরো কিন্তু এখানে ডাইভার্ট করে দেওয়া হচ্ছে। তা আমি কিন্তু তাদেরকে বলেছিলাম যে আমাদের মেইন অবজেক্টিভ তবে হাতির যে একটা হিউজ জায়গা, এখানে এত ফ্লোটিং ম্যাট বসানো একটু বেশ ব্যয়সাধ্য, কিন্তু আমাদের 3টা যে ক্যাচমেন্ট যেখান দিয়ে যাচ্ছে, সেই ক্যাচমেন্টে কিন্তু আমরা এই ফ্লোটিং ওয়েটল্যান্ডটা বসাতে পারি। কারণ এই 3টা ক্যাচমেন্ট থেকেই কিন্তু হাতিঝিল আছে। আমি যে ক্যাচমেন্টটা যদি ফ্লোটিং ওয়েটল্যান্ড দিয়ে বসাই দিই, হ্যাঁ, তাহলে কিন্তু পলিউটেন্ট কিন্তু অলরেডি কিন্তু কিছুটা কমে যাবে, এবং প্রত্যেকটা চ্যানেলের কিন্তু একটা সেলফ পিউরিফিকেশন ক্যাপাসিটি আছে। কেন আমাদের হাতির ঝিল ইয়ে করতে পারছে না? কারণ সেলফ পিউরিফিকেশন ক্যাপাসিটি এক্সিট করে গেছে। আমি যদি 3টা ক্যাচমেন্টে আমি যদি ফ্লোটিং ম্যাটটা দিয়ে বসায় দিতাম, তাহলে কিন্তু আমার ওই ম্যাট পাস করেই কিন্তু মেইন হাতির ঝিলে যেত। তাহলে কিন্তু আস্তে আস্তে কিন্তু মানে ওই কন্টামিনেটের মাত্রাটা কিন্তু কমতে থাকতো হাতির ঝিলে। তারা এখন ওখানে যেটা করলো যে পরে যে কি জানি আমি দেখলাম পরে যে অ্যারেশন কি জানি বা ইয়ে করলো, ইট ডিডন্ট ওয়ার্ক, এটা ওয়ার্ক করে নাই। হাতিঝিল এখনো সেই গন্ধই আছে। এখানে অল্টারনেটিভ কোনো অপশন নাই। আমার এখানে মেইন জিনিসটা বুঝতে হবে, মেইন জিনিসটা হচ্ছে আমাকে ক্যাচমেন্টটাকে ঠিক করতে হবে, ক্যাচমেন্টের কন্টামিনেন্ট আমাকে আগে রিমুভ করতে হবে। অন্ধের মতো তো আমাকে দৌড়ালে হবে না, তাই না? এখানে হচ্ছে মেন। আর বুড়িগঙ্গার সমস্যাটা যেটা হচ্ছে, যে কোনো নদী, আমি আগেই বলেছি, ফ্লোটিং ম্যাট কিন্তু আপনি নদীর দিতে পারবেন না। নদী একটা বিশাল জিনিস, কিন্তু কোথায় চলে যাবে, কিভাবে বাঁধবো আমি? হ্যাঁ, জাহাজ যাচ্ছে, ওই যাচ্ছে, নৌকা যাচ্ছে, ও কেটে দিবে। কিন্তু আমি যেটা করতে পারি, প্রত্যেকটা ইন্ডাস্ট্রি কি করে, ইন্ডাস্ট্রি কিন্তু সরাসরি নদীর যায় না, একটা চ্যানেল ওরা কিন্তু করে, ওই চ্যানেল দিয়ে কিন্তু যায়। আমি যদি পুরো চ্যানেলটা দিয়ে যদি আমি ফ্লোটিং ম্যাটটা বসাই, তাহলে ওই চ্যানেলের মধ্যে থেকে কিন্তু ইন্ডাস্ট্রিয়াল ওয়েস্ট ওয়াটার যেতে থাকবে, এবং কন্টিনিউয়াস কিন্তু পিউরিফিকেশন হতে পারে। এবং এই চ্যানেল কিন্তু ছোট না, 1 কিলোমিটার 2 কিলো লম্বা চ্যানেল আছে। এবং এই ম্যাট গুলো কিন্তু আপনি যত এমন করে, এটা কিন্তু খুব একটা একদমই চিপ। আপনি পিভিসি ম্যাট নিয়ে আসবেন, পিভিসি ম্যাট নিয়ে এসে, যেটা আমি প্রফেসর নাথ যেটা জিজ্ঞেস করেছেন, এটা আমি এখানে উত্তর দিই, এখন আমার মনে পড়লো যে এই ম্যাটে আমরা কিন্তু বিশেষ করে ফ্র্যাগমাইট বা কলাবতী, এটা একটা সবচেয়ে সুবিধা হচ্ছে কি, এই নেটের মধ্যে দিয়ে এটাকে বসায় দেওয়া হয়। এবং এই ফ্র্যাগমাইট আর কলাবতী এই যেটা করে, এই ওয়েস্ট ওয়াটার যে নিউট্রিয়েন্ট সেটাকে এক্সট্রাক্ট করে তারা বড় হয়ে ওঠে, যেটা আবার ভেটিবার পারে না। ভেটিবার কিন্তু আস্তে আস্তে দুর্বল হয়, মারা যায়। তার জন্য খড় বা কয়ের নেটের মধ্যে একটা মিডিয়া হিসেবে দিতে হয়। ফ্র্যাগমাইট বা ভেটিবার ইয়ে কিন্তু ক্যানা ইন্ডিকা কিন্তু এই এটা না। যেমন আপনাকে আমি দেখাই, আপনার প্রফেসর নাদেরই যে কোশ্চেনটার উত্তর এই যে এখানেই চলে আসবে। এই যে এখানে কিন্তু একটা ফ্লোটিং ম্যাট সম্ভবত, এই যে কোন একটা, এই যে এটা কিন্তু কেন দেখে কিন্তু বোঝা যাচ্ছে না যে এর মধ্যে কিন্তু ম্যাট আছে, কিন্তু এটা কিন্তু এই যে ম্যাট নেটের উপরে ঝুলছে, আর কিছুই না, নেটের মধ্যে বসায় দেওয়া হয়েছে। ও রুট গুলা ওখান থেকে নিউট্রিয়েন্টটা এক্সট্রাক্ট করে বড় হয়ে উঠছে। তা আপনি চিন্তা করেন যে একটা ম্যাট এটা বানাতে কতটুকু, পিভিসি ম্যাট। আপনি কেউ যদি চায় ককশিট ছিদ্র করে ওর মধ্যে হয়তো ক্যানাইন্ডিকা বসাতে পারবে না, কিন্তু ফ্র্যাগমাইটের শুট গুলা বসাই দিতে পারবে। এটা খুব একটা খরচের সাপেক্ষ ব্যাপার না, এটা ইজিলি করা যেতে পারে। ইচ্ছাটা হলো সদিচ্ছা, আর কিছু না।
Okay, thank you.
Thank you.
Moshami, you can ask your question.
Thank you very much, sir, for giving me the opportunity. And I would also like to extend my thanks to Professor Saeed for a very wonderful work. I have a few questions actually. First one is, though your presentation was very technical, I'm asking questions from a very non-technical point of view. My first question is how we can reap the most benefit of it, say constructed wastelands in urban areas where there is a constraint of open spaces and there is also lack of wetlands. This was my first question. And my second one is whether we could manage the fecal sludge of a mega city, as there is a land constraint, is kind of issues, mega cities like Dhaka using this process. And I have another question, and this is the last one, and that is I would like to know from you the role of constructed wetlands in circular economy, actually, because we have to think in a holistic way and how it would contribute to the whole economic process. I just want to know from you. Those were very non-technical. Thank you very much. Thank you.
Thank you. Regarding your first question, the wetland, sludge treatment wetland, that means they have been already implemented in defined Purosabha. For example, Shokipur Purosabha, Soyodpur Purosabha. I think now in total 150 sludge treatment systems exist. What they're doing, they're collecting the fecal sludge or human waste, they're putting it and they're treating it. But the main problem is they do not know how to manage the overall sludge production, because our main objective regarding the second objective, circular economy, we should produce fertilizer from this one, because human waste, it is also a great source of fertilizer if we correctly process it, because we have to remove the coliform concentration. So the municipalities now, they have implemented many sludge beds. And also, you know, in the Rohingya community, all the NGOs, they are now treating the waste produced from the Rohingya community with this wetland system. Otherwise, the ocean would have been polluted right now. So it has already been implemented. But now the question is regarding circular economy, how we can produce manure or fertilizer from this septic tanks or maybe fecal human waste sludge treatment system. This is the research that I am now undertaking, and alhamdulillah, by the grace of Allah, we have found some promising results about how we can produce fertilizer that can meet the guideline published by the ECR or maybe Department of Environment. So we are working on this aspect, that means circular economy. because it will produce fertilizer. And if we think in a holistic way, every day, tons, 1,000 tons, metric tons of human waste, it's going out. If we manage it in a sustainable way, we can produce huge amount of compost or fertilizer. If we meet the guidelines, all the guidelines, that it doesn't contain any harmful substance, because now I'm very much concerned about because like the pharmaceutical product, because we consume pharmaceutical and that is going in the septic tank system. If we meet all these guidelines and the new guidelines that have been published by the other parts of the world, we can easily use it for the fertilizer with the help of our agriculture friend, because they know how to manage or how to increase certain components of the sludge. So it is a very huge prospect, I believe. And we are heading towards that way.
Thank you, Professor Saeed. Now, sir, Dr. Mohammad Tariq sir. Sir, you can ask your question. Sir, sir.
To be honest, I have no questions or queries, but I just want to have some observations. First, at the end, you said that you need friends from agriculture. Do you think, I may assume that your team have plant experts and people from other disciplines, because you are using different kind of plants who is helping water to be purified through different methods that you have developed over time. Second, sort of in any of your paper, you haven't, there was a question of upscaling. Actually, if let me first say that all your research are fascinating, and to translate those findings into real application and policies to be taken by the government, there need to be some cost analysis. You talk about optimal solutions, but what will be the costing of certain methods? Because ultimately that will define that how cost and benefit will outweigh the cost of these methods. And my third sort of whether you have approached the authority for any of your research finding to be applied by the Environment Ministry or the concerned department, and what was the response? Thank you. Thank you, Chair, and thank you, Professor Saeed, again.
Thank you very much for your nice questions. Actually, for reducing the cost, we have focused on rejected materials. For example, I have shown you recycled bricks, or maybe sugarcane bagasse, or maybe concrete mortar. All these are very much abundant, or they are thrown as waste product. Let me give you an example. We have used jhama brick. Jhama brick means the brick that is overburned in the brick industry. Every day, tons of jhama bricks are being produced, and they are thrown in the environment because people, they do not know what to do with it. We have used it, and we used it at the media, and we purified the wastewater. That's why I was focused on waste material to reduce the cost, because media is a substantial cost, and if we can procure the waste material, it will substantially reduce the cost. Another cost is plant. Obviously, Cana indica is a cost.
Dr. Professor Tanveer, you are absolutely right, but actually ultimately the issue whether one of your research will be replicated or not depends on sort of cost benefit analysis. So have you ever thought of that issue? That is my query. That was my query.
It has been already,
not that I have seen that all along you are using things that are even not, waste products. But the issue is whether you have any point of time thought of costing and placing your proposal to the authorities for that, because the issue is burning issue for Bangladesh, and your research findings are fascinating. So I think we as a nation, we need to do something about our water and our air. But I think it is high time that we should replicate some of your research findings. Thank you.
Thank you. Already 150 real scale sludge treatment wetlands exist in defined Poroshobas like Saeedpur Poroshobha, Shokipur Poroshobha, in Chittagong. So it has been replicated. So people have adopted my idea and they have implemented for sludge treatment. Okay, and the Bill and Melinda Gates Foundation with Public Health, Department of Public Health, they are working to implement these wetlands for fecal sludge treatment, and also they are now waiting for the outcome of the sludge treatment system that I'm now undertaking, because we have to modify the design equation because some problems are existing now in the sludge treatment method. Regarding wastewater treatment, we have already implemented. If I can show you, in the Saeedabad drinking water treatment plant, this is the main treatment plant that supplies drinking water in Bangladesh, and this is the intake. This water is going to the Saeedabad treatment plant. Almost 300 floating mats were implemented by the WASA, and the results were coming good. But I don't know, maybe the whole 2020 we worked together, but from 2021 they disappeared. I don't know what happened. They simply disappeared. I myself worked here without any cost. I didn't take any limit. To tell you frankly, I spent money because I sent my students to observe whether everything went right. But for some unknown reason, I do not know why they disappeared. But if we had completed this project, the intake project, purifying project, it could have reduced the load in the Saeedabad treatment plant, because the water that is being produced by the treatment, particularly in the winter season, it is very much polluted, because this Shitalokha river, it is polluted in the winter season because water volume is reduced and pollutant concentration is increased, and that enhanced pollutant cannot be removed by the treatment plant, because that is a drinking water treatment plant, not a wastewater treatment plant. That's why we proposed that, okay, we will purify the intake. And we did 40% of the work, or maybe 30% of the work, or 25% of the work. But again, for completing the remaining 75% of the work, I don't know what happened. They disappeared.
Thank you. And Farabi, you have any question?
I had a question. Thank you, sir. I had a question, but Dr. Tarek sir has told about the question, but I want to again reiterate the question. So thank you, sir, for giving me the floor. I really enjoyed Dr. Tanveer's wonderful presentation, and I appreciate his and his team's effort in the field of environmental protection. And today he has discussed on a very important topic, I must say, and his research shows that very high efficacy in treating waste water. However, we see the water of Hatirjil and Buriganga is getting more polluted day by day. So I wanted to know if there are any developments in adopting these technologies on a large scale, and what are the main or key challenges in implementing such technologies? So if you just say it shortly, Dr. Tanveer. Thank you. Thank you for giving me the opportunity.
The main challenge is to implement this floating wetland, for example, to treat the Hatirjil, is to purify the intake. We have to purify the intake channel. If we cannot purify the intake channel, Hatirjil will not be restored, the environmental condition. And it requires some time. Even if you implement this system, it will require maybe 1-2 years, because nature, it doesn't work in overnight. It takes a longer time to get polluted, but once it gets polluted, it takes maybe a decade or maybe 5-10 years to restore itself. Look at the example in China. They have implemented this system widely. all their systems were polluted, but now they have restored. They have restored their environmental system. We could also restore, but again, the main challenge is the authority. They should be willing to implement this system. Otherwise, we can shout, but nothing will happen.
Thank you, sir, for your answer.
Okay, thank you. But before I end, I have one query and one observation. Oh, yeah, we have one query from Ms. Sabrina Nas that you have any plan to apply some of your research funding in Russia area? Professor Saeed?
Right now, I do not have any plan
Okay.
to apply this in Russia area because
Okay, then
have any
okay,
plan.
sorry for that. I have one observation and one query. First one is we are taking some measures, as you mentioned, for Hatirjil water purification, keep Hatirjil water purified and also away from bad odor. We have taken some technology from maybe Monash University from Australia.
Australia, yeah, Australia.
So they came here and worked, and they put a perforated, tube system under the water at the bed of the Hatirjil, and water is coming out. Water pooling is, for aeration, so that the oxygen, dissolved oxygen increases and the natural decomposition takes place. That is one. At the same time, we use some chemical also in the process. So it was a natural and chemical kind of combination of the water treatment. But problem is with the water, the polluted water coming from behind the Niketan area. You know that there is one lake from Niketan area. Another one is coming from Police Plaza, beyond the Police Plaza, and the third one is coming from behind the Shunarga Hotel. So there are these entry areas. If you have this floating technology put there, there will be maybe some percentage of purification already on the way before entering into Hatirjil area. So these are the wetland already available. The Gulshan Baridara Motizil Lake, Gulshan Baridara Banani Lake, and that can be. So we have seen that the high polluted water is entering into Hatirjil from Niketan, from the Gulshan area, also from behind the Shunarga area. So these are the places already there, as you have put in Matuel. From the picture, I can see this kind of floating, some bed could be placed there. So Raju can now maybe City Corporation or Raju can take your service, technological service from your work. This is one thing. But my second question is that this technology will protect, will protect environment through pollution control, but at the same time, the material you use, the vetiver grass or the other plants you are using, also the media, and I would say that these are all also at some point of time will be polluted with, contaminated with heavy metals, with other pollution. So, what are the plans to dispose of these materials used in the technology with environmental, environmental disposal of this material when it will be upscaled? It will be put in bigger scale. There will be huge amount of media will be coming, and also the plants will be coming. Those were already contaminated because it will not be recycled for many years. You have to dispose of these media and other plants that will be already contaminated because of less efficiency or because of the age sort of thing. So what will be the environmental disposal of these materials you will be using in your technology? This is a query from me.
ধন্যবাদ, বাংলায় বলি মনে হয় এবার।
জি জি।
তো আমি প্রথমে যেটা বলছিলাম যে ওই যে এরেশন, একটা জিনিস আমাদেরকে বুঝতে হবে, আমি এরেশনটা করছি যেখানে এই হাতির ঝিলের যত সলিড সেটা কিন্তু নিচে জমা হচ্ছে স্লাজ হিসাবে, আমি সেখানে এরেশন করছি সারফেসে। তাহলে আমি কি করছি এরেশনে? এই যে স্লাজটা যে জমা হচ্ছে এটা কিন্তু আমি এবার রিসাসপেন্ডেড করে দিচ্ছি, তার মানে আমি আরো পলিউটেড করে দিচ্ছি। কারণ এরেশন মানে তো হচ্ছে এটা টার্বুলেন্স ক্রিয়েট করছে। স্লাজ মানে কি? একটা সলিড লেয়ার, ময়লার একটা আবরণ যেটাকে আমরা জমা হচ্ছে। আপনি যদি সেখানে বাতাস দেন এটা তো টার্বুলেন্স হবে এবং এখানে পার্টিকেল গুলো আস্তে আস্তে রিসাসপেন্ডেড হতে থাকবে। তাহলে তো আমি এটাকে পলিউটেড করে দিলাম। এবং নাম্বার 2, এটা তো আমাকে একটা জিনিস বুঝতে হবে, এই যে ওয়েস্ট ওয়াটারে যে পলিউটেন্টটা আসছে এটাকে ব্যাকটেরিয়ালি রিমুভ করতে হবে। সেটা কি? এখানে হয় আমার অ্যাক্টিভেটেড স্লাজ প্রসেস লাগবে যেখানে ওই যে এমএলএসএস ফর্ম করবে, সেটা এই লেকে সম্ভব না। তাহলে আমার এখানে কোনো মিডিয়া লাগবে। মিডিয়া বলতে তাহলে আমার এই যে ফ্লোটিং ওয়েটল্যান্ড, এই রুট থাকবে, এখানে ব্যাকটেরিয়া গ্রো করবে। যখনই এর মধ্যে দিয়ে পাস করবে তখনই এখানে পলিউটেন্ট রিমুভ করবে। যার জন্য অ্যারেশনটা কিন্তু স্লাজ লেয়ারে না হয় আমার কিন্তু পানির উপরে সারফেস অ্যারেশনটা হওয়া উচিত ছিল। এটা ঝর্ণার মতো হতে পারতো, উপরে এরকম পানি ছিটাচ্ছে, নট ওই স্লাজ লেয়ারের ভিতরে। আমি সমস্ত স্লাজ যেটা সেটেল করছে ওকে আমি আবার রিসাসপেন্ডেড করে দিচ্ছি, সলিড রিসাসপেন্ডেড।
প্রফেসর সাইদ, আমি আপনাকে বলি ওই পারফোরেটেড পাইপ সিস্টেমটা স্লাজ লেভেলে দেওয়া হয় না। ইট হ্যাজ বিন পুট above the level where I mean the normal water is there. It is not put in the bed of the হাতির ঝিল। এটা আসলে ওই লেভেলে দেওয়া হয়নি, এটা আরেকটু উপরে দেওয়া হয়েছে পরীক্ষা করে, যেখান থেকে এরিশনটা দিলে পরে that will not turbulate, the sludge will not be coming up due to this aeration. So that has been put with calculation. Yeah, okay.
আচ্ছা ঠিক আছে, সেটা না হয় হলো, কিন্তু আমার যখন এই যে ব্যাকটেরিয়াটা গ্রো করবে, ব্যাকটেরিয়াটা গ্রো করার জন্য অ্যাক্টিভেটেড স্লাজ পদ্ধতি কি হয়, অর্গানিক পার্টিকেলের সাথে ব্যাকটেরিয়া অ্যাটাচ হয়ে সাসপেন্ডেড অবস্থায় থাকে, যার জন্য অ্যাক্টিভেটেড স্লাজ পথে পানিটা পুরো ফেনার মতো থাকে, যেটা আমরা ট্রেডিশনাল ট্রিটমেন্ট প্রসেস থেকে। এখানে তো আমার এটা একটু ডিফিকাল্ট হয়ে যাচ্ছে। আমি অক্সিজেন করছি, কিন্তু আমার তো ব্যাকটেরিয়াটা গ্রো করার জন্য আরো করতে হবে, কি বলে আরো সুইটেবল মিডিয়া দিতে হবে। তো সেটার জন্য সবচেয়ে লো কস্ট, এটা যেমন অ্যারেশন, এটা খুব একটা বেস্ট অপশন হতো। এই যে এরকম ওয়েটল্যান্ড থাকবে, মাঝে মাঝে ওই যে ঝর্ণার মতো অ্যারেশন থাকবে, এখানে ঝর্ণার মতো অ্যারেশন করছে, জেন্টলি করছে উইদাউট ডিস্টার্বিং। তাহলে এই রুটের আশেপাশে এক অ্যারোবিক কন্ডিশন ক্রিয়েট হতো, আরো পলিউশনটা খুব ভালোভাবে রিমুভ হতো। এবং আপনার সেকেন্ড কোশ্চেন হিসাবে এই যে আমরা যে মিডিয়া, আমরা তো এখানে কোনো মিডিয়া ইউজ করছি না, যেটা প্রফেসর নাজ এই কোশ্চেনটা উনি করেছেন, এবং মানে উনি এই পয়েন্টটাই করেছিলেন আপনার যদি মনে থাকে। এবং এখানে যদি আমরা দেখি যে এখানে কিন্তু আসলে একটা মিডিয়া এখানে দেখানো হয়েছে, কিন্তু আমি আসলে কিন্তু এখন আমরা যেটা করি এখানে কোনো মিডিয়া ইউজ করি। এই যে নেট থাকে, নেটের মধ্যে ফ্র্যাগমাইটের যে শুটগুলো এগুলো বসায় দেওয়া হয়। ওই যে প্ল্যান্টটা যখন আস্তে আস্তে ফ্র্যাগমাইট তখন কি করে, আস্তে আস্তে ওই যে পানিতে যে কন্টামিনেন্ট অ্যামোনিয়া বা নাইট্রেট, মেনলি অ্যামোনিয়া ফসফেট থাকে, সেটা আপটেক করে করে তখন কি করে, এই যে আপনি যদি এই স্লাইডটা দেখেন ওয়াসার, তখন বুঝতে পারবেন। ওয়াসার স্লাইডটা জানি কোথায় গেল, এই যে এটা কিন্তু ইনিশিয়াল অবস্থা ছিল, এই যে একদম দেখেন প্ল্যান্ট কতগুলো ফ্র্যাগমাইট ঘাস ওই যে পাতা ছাড়া কালেক্ট করে আনা হয়েছে, এদের 2 মাস পরে এদের গ্রোথ দেখেন কি অবস্থা। এখানে কিন্তু কোনো মিডিয়া দেওয়া হয়নি, জাস্ট নেটের ভিতরে প্ল্যান্টটা গ্রো করা হয়েছে। এবং এটা কিন্তু আসলে ডিসপোজ আমরা করব না, প্ল্যান্ট এখানেই কিন্তু সে গ্রো করবে, ন্যাচারালি গ্রো করবে, আস্তে আস্তে ন্যাচারাল ডেথ হবে, এবং ন্যাচারালি কি বলে যে এই ম্যাট বা এখানে পরে ডিকম্পোজ হবে। হ্যাঁ, কিছু মেটাল রিলিজ হবে, কিন্তু আগেই কিন্তু আমরা বলেছি যে প্ল্যান্টের যে আপটেক সেটা কিন্তু টোটাল যে রিমুভাল তার চেয়ে অনেক কম। মেইন আপটেক হচ্ছে নাইট্রোজেন, ফসফরাস, মেইন রিমুভাল হচ্ছে ব্যাকটেরিয়াল। এখন যদি মেটাল থাকে, মেটালের একটা সম্ভাবনা আছে হচ্ছে যে মেটালে এখানে যেহেতু এখানে কোনো মিডিয়া নাই, একটাই হচ্ছে কি বলে যে এখানে প্ল্যান্ট আপটেক, কিন্তু আপটেক গ্রোথ ডেথ তো সবসময় হচ্ছে না, রিলিজও হবে। কিন্তু এটা আমাদের পরীক্ষাও দেখতে হবে, যেটা আমার ন্যাচারালি, যেটা আমার অভিজ্ঞতা বলে আপটেক রেটটাই ডিকে রেটের চেয়ে অনেক বেশি, ডিকে হবে কিন্তু তার চেয়ে আপটেক রেটটা আরো বেশি এখানে, এটা আমাদের আর আপনি যদি আমাদের ওয়েস্ট ওয়াটারে যে মেটাল থাকে, আপনি তো আদার কোনো ওয়েতে এখন ওই অ্যারেশন যেটা আমরা করছি ওটাদের মেটাল রিমুভ হবে না, ওখানে মেটাল কিন্তু থেকে যাবে। মেটাল আর আরেকটা জিনিস, যে কোনো ওয়াটার বডিতে কেমিক্যাল ইউজ না করাটাই বেটার, কারণ কেমিক্যালের কিছু এলিমেন্ট কিন্তু থেকে যায়, যেটা কিন্তু কি বলে চলে যাবে হচ্ছে মেইন ওয়াটার বডিতে। সুতরাং কেমিক্যালের ব্যাপারে আমার মনে হয় আমাদের একটু রেস্ট্রিক্টেড থাকাই ভালো ফর এনভায়রনমেন্টাল প্রোটেকশন। এটা এটা খুবই জরুরি। নেচারে যতই কম কেমিক্যাল ইউজ করা যায় তত বেটার।
ওকে, থ্যাংক ইউ ভেরি মাচ। আমার মনে হয় আমি আর কোনো কোয়ারি আমাদের নেই। সো প্রফেসর সাইদ, থ্যাংক ইউ সো মাচ। আপনি এত ব্যস্ততার মাঝে আমরা দেখতে পাচ্ছি, সবাই অনুধাবন করতে পারছি আপনি রিসার্চের সাথে কিভাবে জড়িত, কিভাবে ব্যস্ত আছেন। ইউ অ্যান্ড উইথ ইউর স্টুডেন্টস। তার মধ্যে আপনি আমাদের বিআইজিএম এর অনুরোধে এবং ইনভিটেশনে আপনি আমাদের রিফর্মের প্ল্যাটফর্মে আপনার এই গবেষণালব্ধ বিশেষ করে কনস্ট্রাক্টেড ওয়েটল্যান্ডস ফর purification of wastewater for environmental protection of Bangladesh, সেটা আপনি প্রেজেন্ট করেছেন। অনেক অনেক ধন্যবাদ। আমি আপনার এই যেখানে আমাদের এই অডিয়েন্স থেকে যে ইয়েটা এসছে, সাধারণ যেটা এসছে, সেটা হলো একটা হলো এটাকে আপস্কেল করা, কোথায় ব্যাপকভাবে ব্যবহার করা যেতে পারে, আরেকটা হলো কতটুকু কস্ট এফেক্টিভ হতে পারে। আমাদের যে 100 ইকোনমিক জোনের কথা আমরা বলছি, অনেকগুলো জোন ইতিমধ্যে অনেকটা অপারেশনের দিকে যাচ্ছে। আমার মনে হয় যে এই টেকনোলজি যেটা আপনি ফাইনালি যে ইয়েতে যাচ্ছেন, বিশেষ করে বায়োকাইনেটিক টেকনোলজি ওইটার সাথে অ্যাড করেছেন, ওইটার হয়তো আমাদের এই ইকোনমিক জোনগুলোতে এটার অ্যাপ্লিকেশনের আমি একটা প্রসপেক্ট দেখতে পাচ্ছি আর কি। আপনি হয়তো এটা চেক করে দেখতে পারেন। আমার মনে হয় দ্যাট উইল বি গ্রেট ফর আস। অ্যান্ড আমি আমাদের বিআইজিএম এর পক্ষ থেকে আপনাকে অনেক কৃতজ্ঞতা জানাচ্ছি, ধন্যবাদ জানাচ্ছি। আপনি আমাদের সাথে কমপক্ষে প্রায় আমি বলবো যে এই ওয়েবিনিয়ারে প্রায় 2 ঘন্টা আছেন। তার আগে প্রিপারেশনের জন্য অনেক সময় দিয়েছেন, এর জন্য আপনার কাছে আমরা কৃতজ্ঞ। আমরা ইউনিভার্সিটি অফ এশিয়া প্যাসিফিক, তার সাথে আপনাদের সাথে আমরা কাজ করতে চাই। আমাদের শ্রদ্ধেয় পরিচালক মহোদয় এখানে আছেন, তিনি আমরা এটা শুরু হলো। আমি ইউনিভার্সিটি অফ এশিয়া প্যাসিফিক তার শ্রদ্ধেয় ভাইস চ্যান্সেলর, তাকেও আমরা এখান থেকে কৃতজ্ঞতা জানাচ্ছি আপনার মাধ্যমে, যে উনি এখানে এটার ব্যাপারে ইন্টারেস্টেড ছিলেন। আর আমি আমার এখানে যারা বিআইজিএম এর রিসার্চ প্ল্যাটফর্মের যারা রিফর্মে যারা এখানে জয়েন করেছেন, তাদেরকেও ধন্যবাদ জানাচ্ছি। সেই সাথে ডক্টর তারেক স্যার আজকে সারাদিন অফিসের যথেষ্ট পরিশ্রমের মধ্যে, সিনিয়র স্যারও এখানে সময় দিয়েছেন, আমাদের সাথে প্রায় 2 ঘন্টা যাবত আছেন। আমি সবাইকে ধন্যবাদ জানাচ্ছি এবং কৃতজ্ঞতা জানাচ্ছি। আশা করি আমাদের রিফর্ম প্ল্যাটফর্মের মাধ্যমে দেশে বিদেশে যে রিসার্চ হচ্ছে তাদেরকে আমরা ট্যাগ করতে পারবো, এবং যেটা আমাদের মূল লক্ষ্য, যে বাংলাদেশের প্রোডাক্টিভিটি উইথ রেসপেক্ট টু নলেজ প্রোডাকশন, উইথ রেসপেক্ট টু ইকোনমিক প্রোডাকশন, আদার প্রোডাকশন, আমরা সেটাকে করতে পারবো এর মাধ্যমে। I wish all the best and please take care and stay well. Thank you so much. Bye.
Thank you, Professor Tanveer. Thank you on my behalf and on behalf of BIGM. Wonderful works, fascinating works, and I think it will help our country a lot.
ধন্যবাদ আপনাদের সবাইকে আমাকে এখানে আমন্ত্রণ করার জন্য। আমিও খুব এনজয় করেছি, কারণ রিসার্চ ফাইন্ডিং ডিসিমিনেট করাটা আসলে একটা রিসার্চারের দায়িত্ব, এটা কর্তব্য এবং দায়িত্বের মধ্যে পড়ে। সেটা আপনার ওরালি হোক, পেপার তো অবশ্যই, ওরালিও ডিসিমিনেট করা একটা দায়িত্বের মধ্যে। আপনাদের সবাইকে ধন্যবাদ জানাচ্ছি, এবং পার্টিকুলারলি আমি এখানে প্রফেসর নাজকেও ধন্যবাদ জানাচ্ছি। তিনি, আমি দেখলাম উনি আছেন, উনি আমার আত্মীয় হন, তাকেও ধন্যবাদ জানাচ্ছি। আপনাদের সবাইকে আমি ধন্যবাদ জানাচ্ছি।
Thank you.
Thank you.
Thank you, everyone.